Ready? Can you hear me? Sweet. Okay. Let's go. Yeah. Right. So Kareem said to me one day, he goes, Mike, I need somebody to fill a slot. Think of something. So I thought of something. It's almost a bit loud. Just a minute. Is that better? Yep, we're good. So a conversation I'd been having a day before with somebody, they're asking, what's the difference between Terraplan and, Terraform and Python and all this sort of stuff. And I thought, hey, that'd be a good thing to talk about. So my name's Mike Mackay. I'm actually the competition over there. I'm with DevNet. If you actually look at most of the team here in Cisco U, they're all ex-DevNet people. So we're sort of like one big team with a little bit of, competition. I'm head of developer advocacy in DevNet, which, by the way, sounds way more extreme than it is. I've got like 9 DAs, so it's not like I've got 1,000 DAs reporting. I've got nine. So my name's Mike Mackay, and this is my, I think I counted it 7th time here. So, it's always good to be here, based out of San Jose. Obviously, as you can tell, I'm not from San Jose, I'm a Kiwi, but been living in the States for like 26 years or something. So, actually, I put my glasses on, sorry. So there's about 5 sort of levels of languages that people talk about. I'm going to talk about 2. The rest of them are sort of nuances within that same block of 2. We're going to talk about procedural and declarative. Procedural is exactly what it sounds like. You define a series of steps that you go through it, and you go from A to B to C to D, and then it's done. Declarative, so Ruby, Python, Go, they're all procedural type languages. And then you have declarative, where you say, I want this to happen. You're declaring what the end state is. You're not declaring how you get there. You just say what it is you want to happen. Terraform, Ansible, SQL, APIs, generally speaking, are considered to be declarative. And then in certain aspects, Python is also declarative. So, none of this is absolute. I'll make an example of of the 2, procedural. So we're going to make some jambalaya. If I'm going to do it procedurally, I'm going to go to Amazon. I'm going to say, send me some ingredients. Then I'm going to saute the chicken and sausage. I'm going to saute the veggies. I'm going to add rice, liquids and seasoning, cook it, and then add the okra and the shrimp. So I know how to make a good jambalaya. And then you taste it and eat it. That's how you do it procedurally. If I'm going to do it declaratively, I log into Amazon and say, send me jambalaya. So one of them, you go through it step by step. And obviously, left-hand side, way more flexible. But if you can't cook, you end up with something random. The declarative, everything's predefined. You just say, give me what I want. So that's the major difference between the 2. Now, in procedural, as an example here in actual code, here is a simple example of creating a VM inside of vCenter. And as you can see, there's a lot of stuff going on in here. So you've got to deal with your authentication. You've got to check variables. You've got to do all sorts of fun and games. And then you've got to make sure you power on the VM, et cetera, et cetera. So I'm not going to go through this line by line because that's not really the intent. So that's a procedural example to create a VM. Now, if I do it in declarative, in this particular case, Ansible, exactly the same piece of code to achieve the same result, all I have to do up here is I define what cluster, what's my data store, what's the folder, what am I going to call it, what's my operating system. So I just provided a bunch of parameters, and then Ansible goes out and does some magic stuff, and we end up with the VM being created inside of vCenter. This way here is obviously a lot easier if you have absolutely no clue on how the vCenter APIs work, which most people don't know how the vCenter APIs work. And if you ever call vCenter, they don't know how they work either. So if you ever want to talk trash about vCenter APIs, just give me a call. I can do it all day. But as you can see, it's a lot simpler. This syntax here allows me to pass parameters in, so you can still parameterize it. You can pass things in. You can do a little bit of logic using the Ginger templating type thing, but generally speaking, it's about as simple as that, just to do something like that. So what are declarative languages? SQL, if you think about SQL, a lot of people, it's like set value X where this field equals Y. It's declarative. You don't care how it happens. You don't care if it's running on Microsoft SQL. You don't care if it's on Oracle or Postgres. Really not an issue. You're defining the desired state of it. Terraform. Terraform's just a data model. You just give it the parameters and it does it. Ansible, same thing. And Python can also be considered in certain aspects declarative. You don't care how, if you do an API call or you do something else in Python, you don't really care how it works. You've got this library that sits underneath and does all sorts of magic stuff for you. So in that particular instant in time, Python is declarative. The rest of the time, it's obviously procedural. RESTconf, NetConf, GNMI, they're all data model-based languages, and you define a desired state, not how you get there. That's not your problem. Then we talk about infrastructure as code. Now, what you often find is people talk about infrastructure and code, and they're talking about AWS and GCP, and they're talking about creating VMs and stuff like that. Really, it's basically creating a piece of data, a data model, and saying this is what I want. Now that can be networking. If you actually go to the DevNet stuff, and actually here as well, a lot of conversation about how do you build or how do you update CDO using Terraform, et cetera, as opposed to the more, if you go to KubeCon, all they talk about is how do you do this inside of Kubernetes. And it's normally defined as in a definition file, and they use fairly standard formats. YAML's the most common one, which stands for yet another markup language, because we need another one. And you'll see that one. Anybody that's seen it, if you're modern languages, use it a lot. Yang is a slightly different model, and that's what you use for NetConf, RESTconf, et cetera. And there's a few other ones that you can also use, but primarily they're the major ones that you see it. So anybody that's had to deal with configuring an Ubuntu system, this is the configuration example of a NetPlan configuration file for Ubuntu. And this is done in Yang. And so we have the network, we have the version. These are all just parameters, key value pair parameters. If you were doing this in JSON, it would be almost the same, except you stick little curly brackets. The important thing in here, though, is indentations and stuff like that can become really important. But if you look at this is fairly easy, machine readable, human readable, it's parsable, pretty simple to deal with. There are certain rules and regulations around it. JSON also is quite common. JSON's harder to read unless you're used to reading it. I can read JSON. I could read a book in JSON. I wouldn't even worry because I stare at that stuff for so long. But YAML is considered easier to read. I'm not convinced on that personally. Don't know what you think, Quinn. I prefer JSON. It's more structured, but whatever. So Santa is not real. Sorry, guys. He does not exist. And there is no magic. Probably not. Somewhere, somebody has had to do some work to make all this stuff actually happen. So when you read if you look at that piece of Ansible code that we showed earlier to create a VM, and then you look at the procedural code that I had there, somebody somewhere has written a whole library to make all that stuff happen. Contrary to popular opinion, writing something in Ansible is not magic. If it's Ansible, it was probably written in Python. Doesn't have to be, but it kind of has to be. You can make it do other things, but it's kind of weird. And Terraform uses a thing called HCL, which is HashiCorp config language. But even then, HCL really is just a reference pointer to other stuff. So it points at something that's in Go or in Python or some other language. So those are the primary languages that these things run on top of. I'm going really fast, aren't I? All good. Oh, you actually may be finishing early. This is my first time of doing this, so I wasn't quite sure how fast it would go. So it might be like 5 minutes, and then you can go and get some lunch. So what I was going to do next was actually a demo. What a demo. Demo is maybe an overstatement. I was just going to show you some examples of some stuff. So, and the reason why I want to go back down to this whole magic thing, because if you look at an Ansible module, underlying that is probably some Python code. Underlying that Python code, there's probably API calls. Each of those has to be developed by somebody in vCenter wrote the SOAP API. Somebody wrote an SDK that sits on top of that SOAP API, and then somebody wrote the software that Ansible talks to, and then somebody wrote the Ansible modules that sits on top of that. So all of that stuff still has to be done, and you can do a lot of it yourself. You can write your own Python code, and then you can wrap it inside Ansible, and then somebody somewhere can just say, I want to do this, and the magic does actually happen. So just want to do some simple examples. So this is actually from Meraki. Oh, no, I'm not. Come on. Oh, there we go. Oops. So at the time I wrote this, hopefully you can read at the back, Meraki didn't have a way of allowing me to move licenses between orgs. So I wrote, they had the APIs for it, but they didn't have it in Ansible. So I ended up writing a Ansible module that allowed me to take licenses and shuffle them around between different orgs inside Meraki. They may actually have an Ansible module for it now. And basically, all I needed to do was I needed the organization ID, I needed the type of license, how many, and then what was I going to do with them. So what I have done here is just really make a very simple way of saying I want to move my licenses from here, and I want to move them to here. Now, that, in actual fact, does actually require, where did I put it? This, in turn, requires this much code that Mike had to write. So there is no magic. These are all the API calls required by Meraki in order for me to move those things. However, by extrapolating that, or just abstracting that, I should say, really, into this simple little thing here, it means that anybody that now needs to be able to move licenses between orgs that's using my libraries can now just apply those simple parameters, and then they get moved. However, the magic still had to happen underneath. The other one I was going to quickly show you, so was in Terraform. Now I've lost my bookmarks. Sorry, guys. I was fixing laptops before I got here. I'm a bit discombobulated. I am going to... here we go. Who uses the DevNet Sandbox? Yes, we have one candidate. So the DevNet Sandbox, just for the record, since I run the team, we provide sandboxes for anybody that wants to use Cisco products. It's more focused on the developer piece than product demo. So if you're trying to go in and work out how a product works and use the GUI and things like that, you'll be using dcloud generally. But the DevNet Sandbox is really focused on people that want to work out how the APIs work, how to authenticate against a product, all that sort of stuff. And we are having challenges. Here we go. So as a result, we have all these sandboxes like dcloud, but they're really focused, like I said, on developers. And the reason why I'm asking is we're about to do an upgrade. So if you use DevNet Sandbox next week, you'll see a different look and feel. This is this one. So if I come into here and I look, and I'm just going to... If I come and look at this, who uses CML? A few of you? Come on, you need to use CML. It's awesome. It is the bomb. You got to work out what CML is. Go and talk to the CML guys. But it's a modeling language. You can build an entire topology of Cisco products and servers and all sorts of other things, all running inside a single VM. And you can do things like bouncing links. You can add stuff. You can configure it. It's really, really great for doing testing and automation on, and just for validating stuff. So you need to work it. You need to do CML. Anyway, so if you want to build a CML environment from code, it takes a lot of lines of code to do it. in the sandbox environment, obviously, because our job every day is automation. That's what we do. We automate sandboxes. We have written the Terraform pieces that make it work. And so for us, in order to build the way we've done it, we have a simple thing like to build a CML instance. All I need to do, this looks pretty bad, but it's not as bad as it looks. All I need to do is pass in a whole bunch of parameters. I need to pass in username, password, and tokens, and all that sort of stuff that you always have to have. But all I need to know is how much CPU, how much memory, what's my simulation, and what version of CML. That's really the only out of all that, apart from the authentication stuff. That's all that's needed. And that's in my Terraform module. Once I execute that Terraform, it will go out and completely build a whole CML instance for me, bring it up, install the simulation. It goes through, it licenses it, it validates it, brings up the simulation, and then it goes through and tests the simulation to make sure the simulation is working. And I can do all of that in about 10 lines of Terraform. If I want to do that procedurally, I've got 500 lines of code to do that. But we're able to do this, and it's very simple. We just pass in parameters and things happen. How am I going for time? Wow, I'm only on 16 minutes in. That's pretty good. So that is the difference between declarative and procedural. Procedural, a lot more work, a lot more flexibility. Declarative, you just define what you want to do. Requires a lot more work behind the scenes for people to get it going. But once it's done, it's just rinse and repeat, rinse and repeat, rinse and repeat. That was way quicker than I was expecting it to be. Any questions? So what you should really do is you start off life. Well, if somebody's already got Terraform modules and if somebody's already got the Terraform modules and everything written, then you use it. If you want to do something that's not covered already, then what I would normally do is you have to use procedural anyway, just to do it. So you would go through, you would do it using the API. You might use Postman and whatever you need to do, and then write it, work out how it works. And then if other people are going to be using it and you need to put it into a pipeline or you need things like that, then you basically take the Ansible and you take that procedural code that you've written and you stick a wrapper on top of it that allows Ansible to talk to it. And if you want to later, I can show you how we do it. I've got a sort of some boilerplate code that you can just stuff Ansible into Python into it, and it spits out Ansible or talks cleanly in Ansible. So if you ever want other people to do things and you want to do it consistently, then you should wrap it in Ansible, Terraform, or something like that. And then you should also be trying to use some sort of single source of truth, like Netbox or whatever thing. But you should try and not have things like IP addresses and security passwords. So if you're using security, you should be using something like HashiCorp Vault or Ansible Vault or something to store all that stuff. So you should try and then pull all those pieces in. You can stick it inside of an Ansible module. All of that stuff then gets made invisible to the end user. So somebody using it doesn't need to know the password to log into your particular device and then do the enable password. Doesn't need to know that. They don't, and so you can hide all that stuff on them as well. So it makes it a bit more secure. But then, so yeah, one-off stuff, just procedural's fine. But if you're ever going to reuse it, then you should wrap it in something else. And like I said, wherever possible, use never, ever, ever pass passwords in code. Never. Best, shouldn't even put them in the command line. You should set them as an environment variables. So you actually have an environment variable get set, and then you use it. Or you go out to Vault and you grab them and you bring them in. Otherwise, you're just going to get hacked one day and you wonder why. Sorry, but that's just the rules. Any other questions? No. Okay, that took way less than I was expecting. I have to rewrite it and take 30 minutes now. Well, thank you. Now I get to put my hand in a bag. Nope, stay, don't go. You might win a prize. Sit. Oh, you don't want a prize? Come on, sit. Oh, there you go. Put it in there. Okay. He's going to win because he's the only guy that asked me a question. What number do we need? 1635. Yes. Sorry. Jesus, getting old sucks. 1635. 31. 3-1. We have a winner. Thank you. Sorry, guys. That was should have been a bit longer than that. Like I said, it's the first time I've done it. Wasn't quite sure how long it was going to take. Next time I do it, I'll suck up more of your time. But fundamentally, that was it. Thank you. Is that it? I just give it to him.